We're going to be talking about the immune system and how it works to protect our bodies from pathogens. I'd like you to think about a castle or a fortress and some of the things that would be used to defend it, to protect the people inside from invasion or enemies. Think of some of the things that might be used to protect that fortress. In my example, you can see I have a number of defenses for this fortress. I'm going to use these to help demonstrate for you what we call the first line of defense of our immune systems. This is part of what we refer to as innate immunity or natural immunity. In other words, physical barriers or chemical defenses we are born with that help protect us from a wide variety of pathogens. Let's talk about what the defenses in my example represent. First of all, we have the walls of our fortress. They form a barrier between what we want to protect inside and everything else that's outside the walls. Just like the walls of this fortress, in our bodies, our skin does this. It's the largest organ in the human body. It covers almost all of the body, and not only is it preventing pathogens from entering our bodies by acting as a barrier, but we also have glands in our skin that produce sweat and natural oils all the time. These act as chemical defenses to help trap and kill the pathogens on our skin. The next element of defense that we have in our fortress is the door that's guarded there in the front. This is representing the mouth. Our mouths help protect us from pathogens in a couple of ways. First, we have saliva that we produce in our mouths. The saliva is another chemical defense against pathogens that we breathe in through our mouths or that we may get into our mouths when we touch our mouths or eat without washing our hands or do things like, say, chew on the end of a pencil and allow pathogens from contaminated sources into our mouths that way. If we happen to ingest a pathogen, if we swallow it as part of our food or water, or a pathogen gets into our mouth and our saliva doesn't kill it, the digestive juices in our stomachs also help kill the pathogen. Next, we have some archers on the tops of our towers. They're looking out for enemies and they're also helping to protect our fortress. I'm using these to represent our eyes. Our eyelashes act as a barrier against pathogens. The hairs of our eyelashes trap them and prevent them from getting into the vulnerable membranes in and around our eyeballs. Also, as a chemical defense, our tears can wash pathogens away that may have come in contact with our eyes and also work as a chemical defense to kill pathogens. The last thing our fortress has protecting it is a guard dragon. In this case, the dragon's representing our nose. You have many tiny hairs lining the inside of your nose, and these are called cilia. They work as a barrier to trap the pathogens and prevent you from inhaling them through your nose. You also have mucus that's produced in many different parts of your body. Anywhere you have mucus lining a passage of your body, that mucus is trapping and killing pathogens, acting as both a barrier and also as a chemical prevention. Obviously, this isn't a true representation of the human body and the first line of defense against infection by pathogens, but thinking about your body as a fortress, these different mechanisms working to protect us from pathogens getting into our bodies to make us sick or harm us, this really helps illustrate that. So generally speaking, most invaders that might be trying to get into your, let's say, fortress are going to be stopped by one of these mechanisms of the first line of defense. Sometimes, though, we're going to have an invader that's able to make it past this first line of defense. Maybe it's an enemy that can't be defeated by your soldiers, archers, or dragons. In other words, a pathogen that's not trapped by hairs or mucus, or not killed by sweat, tears, saliva, or digestive juices. Or maybe our fortress wall has been weakened or broken through, allowing the enemy a way to slip past. This would be like a scratch or cut or puncture in your skin. In that case, the pathogen has made it past the first line of defense. It's breached our fortress. So now what happens? This pathogen is in our body. We have a number of white blood cells in our bodies. They're part of our lymphatic system, which is a component of our immune system. And these white blood cells work to prevent pathogens that do manage to make it into the body from having a chance to multiply and spread enough to make us sick. There are several types of white blood cells, but we're going to simplify things and only talk about 3 of them. The first type of white blood cell is called a macrophage. They will surround or engulf pathogens and digest them to destroy them. So I think of macrophages being kind of like Pac-Man in the way that he chomps down on things and eats them. The word macrophage literally means big eater in Greek. The next type of white blood cell is called a T cell. A T cell is there to determine what kind of pathogen we're dealing with and the best way to fight it. Pathogens all have chemical markers that help differentiate one type of pathogen from another. These chemicals are called antigens, and the T cell is able to identify the pathogen by its specific antigen and then signal other white blood cells to start producing antibodies to fight it. So I think of T cells as kind of like a spy. Their job is to investigate, find out what kind of pathogen we're dealing with, determine what its weaknesses are, and pass that information on so we can defeat the pathogen. So this little spy guy is going to represent our T cell. The last type of white blood cell that we're going to talk about is called a B cell. The job of the B cell is to produce the antibodies that will weaken the pathogen and allow us to fight it off. I think of the B cell as being like a little wizard or magician, and he's creating a special potion or poison to help allow us to defeat the enemy. Now we understand what each of these white blood cells does, so let's take a look at what happens when there's a pathogen that's managed to get past the first line of defense and these white blood cells actually have to go into action. The first thing that's going to happen is a pathogen enters the body. So there's our little germ, our little pathogen, and this could represent any kind of pathogen, a bacteria, a virus, a fungus, any type of pathogen. Now that the pathogen is in the body, our immune system is activated. If you remember, I talked about the first line of defense being an example of innate immunity, a way that our body protects us from infection from lots of generic pathogens. Inside the body, we have another kind of innate immunity at work, and that's the second line of defense, or what's called our non-specific immune response. It's called non-specific because our body reacts the same way no matter what type of pathogen we're facing. Some of the things that are part of this response are inflammation, redness, and swelling. This is caused by blood cells rushing to the site of the infection, and fever as your body raises its internal temperature to try to prevent the pathogens from multiplying. Our macrophage cells, remember those Pac-Man cells? They have a few jobs in our bodies. There are many types of foreign cells that make it into our bodies, even cells we produce, and then they die off or they're unhealthy. If a macrophage identifies a cell that's not a normal healthy body cell, or maybe something like a pathogen that's not from our own body at all, it will engulf and digest that cell. So if a macrophage encounters a pathogen and is able to simply destroy it, the macrophage is contributing to another element of our innate immunity as part of the second line of our body's defense against pathogens. In this case, we may never even feel sick or realize the pathogen was in our body because our trusty Pac-Man cell chomped it before it even had the chance to multiply. There are tons of different pathogens you're constantly coming into contact with, maybe that you've swallowed or it's gotten in through a small cut and you never even realize it. So you may be wondering what happens if the macrophage isn't able to engulf and digest a certain pathogen. And in that case, we move on to our body's third line of defense, and this is known as the specific immune response, or what we call adaptive immunity. And this is where our little spy guy enters the picture. So we have a pathogen, and it's too strong for the macrophage to destroy, or it reproduces so quickly that it's overwhelmed our immune system. And in this case, our body will start sending as many B and T cells as possible to the area of infection, and they'll rush to where the pathogen is and begin to increase in number. Our T cells, those spy cells, they start doing their job of getting information. They're working to identify the pathogen and figure out, based on its antigens, what kind of antibodies would fight it most effectively. You can think of it like the spy sneaking around to gather intel on the enemy and coming back to report what they've learned. Just like the spy guy would pass information to the wizard so the wizard can start cooking up the right kind of potion to defeat the enemy, the T cells send signals to the B cells, so the B cells will start making the proper antibodies to weaken the specific specific pathogen. So now our pathogen is in big trouble because our body is going to attack it with all of those special antibodies that our B cells have produced. This will weaken the pathogen, and now our trusty macrophage, yep, good old Pac-Man cells are back in the picture. So now the pathogen is weakened enough that the macrophage is able to engulf and digest it even though it couldn't before. Kind of like giving somebody kryptonite so they can defeat evil Superman. Once we have antibodies in our blood, our immune system will be able to fight that same pathogen much more quickly if we're exposed to it again. We already know how to fight it and we're prepared. So this is what we call acquired immunity. When we make antibodies ourselves because we were infected by the pathogen and fought it off, the acquired immunity we develop is called active immunity. It lasts for years or often our whole lives. Vaccinations provide us with active immunity as well. Vaccines contain small amounts of dead or weakened forms of a pathogen, usually a virus. By introducing this into our bodies, we give our T cells an opportunity to recognize it, and our B cells start producing the proper antibodies to fight it. Vaccines don't actually infect you with the pathogen, so you don't get sick, even if you might notice some mild symptoms because of the hard work your immune system's doing. But now your body's made its own antibodies to the pathogen. This way, if you get exposed to it later, you'll probably be able to fight it off and not get sick. If the pathogen does infect you, you should recover much more quickly or experience less severe symptoms than people who develop that illness typically would. Acquired immunity can be developed in other ways. Newborn babies' immune systems have never been exposed to any pathogens, so they haven't produced any antibodies of their own yet. The mother passed many of her own antibodies to the baby through the placenta before it was born. These antibodies won't stay in the baby's blood forever, but they will protect it for a few weeks. This protection can be extended for a few months if the baby's fed breast milk, since the mother's antibodies are in her milk too. Meanwhile, the baby's immune system will be fighting pathogens and developing its own antibodies. The temporary immunity the baby has from its mother's antibodies is called passive immunity. Another type of passive immunity can be provided by what are called serum injections. One of these medicines is called immune globulin, basically plasma from the blood of a healthy person who already has antibodies for a specific virus is injected into a person who's been exposed to the virus, or maybe they're at risk of becoming exposed in the near future. For example, maybe you're traveling to a country where there's a high risk of contracting a virus like hepatitis A, but you don't have time to wait for a vaccination to be effective. Serum injection immunities are also called passive because, just like the antibodies newborn babies have from their mothers, this protection is temporary. Even though you've never been aware of it, there's been a battle between your immune system and invading pathogens going on inside your body since you were born. You can do your part to increase the odds of your immune system coming out on the winning side by doing several things. First of all, wash your hands before eating or drinking or preparing food and before touching your eyes, nose, or mouth. And this will reduce the number of pathogens your first line of defense has to work to keep out of your body. Also, it's important to eat well and get plenty of rest and exercise and water. Doing these things will help keep your immune system strong so it can effectively fight off pathogens that do get into your body.